Hi, my name is Irene Lee, and this is my Lab 3 Black Holes and Orbits presentation. So here is my slide for the introduction and setup. So the purpose of this lab is to, number one, determine the mass of a black hole by analyzing star motion and the net forces acting upon it, and secondly, determine necessary initial velocity for a spaceship to complete a figure-8 orbit around planet and moon without crashing by predicting motion. The object, which is a system, is the spaceship, and then the sources would be the moon, planet, and other objects acting with force. And then the model that we used for this lab is GlowScript. And then we found that the result is the massive black hole is 1.26022 times 10 to the 25th, and the initial velocity for the spaceship is negative 3.5 times 10 to the 4th in the x component, and then 2.7 times 10 to the 4th in the y component, and then 0 for the z component. And then here are some of the fundamentals of this lab. We used Newton's second law, which shows the object's net force is its change in momentum over change in time. And then we also used two update formulas, the position and velocity update formulas. And then we also used gravitational force that shows the gravitational force on one object due to another object. And then for net force, we saw F net perpendicular and F net parallel. And then some key concepts would be net force, which um, we looked at both F net perpendicular and F net parallel. F net perpendicular creates change in direction and points towards the center of the circle, while F net parallel indicates change in speed parallel to the direction of motion. So here is part one, initial conditions. To the right is the code that we used. The system is the star, and then the surroundings is the black hole. We are solving mass of the black hole based on the star's motion. And then here are the iteration results for part one. To the right is the code that we used. The black hole mass that we found is equal to 1.26011 times 10 to the 25th. And then the star has a circular motion orbit from the net force, and any potential error could be iteration rounding in this part. And then here is initial conditions for part two. To the right is the code that we used. The system for this part would be the spaceship, and then the surrounding would be the planet and moon. We are trying to find the initial speed of the ship such that it would make a figure-8 shape around the planet and moon. Iteration and results. To the right, once again, is the code that we used, and then we found the ship speed to be negative 3.5 times 10 to the 4th in the x component, 2.7 times 10 to the 4th in the y component, and then 0 in the z component. The ship never really made a figure-8 path, so some sources of error could be a rounding error or a coding error. What does it mean? Net force is equivalent to rate of change regarding momentum, while individual parallel and perpendicular components for rate of change are broken into parts without needing to know the mass of the black hole to calculate position, velocity, and/or momentum. This makes it easier to calculate the net force. What if? So this imaginary system has a black hole, a star, a planet, and a moon. If you wanted to predict the motion of the entire system, what would you need to include in your computational model? Think about all the interactions in the system. Would there be any dominant interactions, or would they all contribute more/less equally? So you must think of each part acting on each system from the surroundings as a whole and separately. The dominant forces would be between the star, moon, and black hole. However, there could be other factors contributing with force. as well.